Good day. So I'm going to show you conservation of momentum. So let's just say we've got a car moving, right? So let's say this car has a mass of 2.5 kgs, right? So that's got a mass of 2,500 kgs, and it's moving at a velocity of 60 meters per second to the east, right? And then here's another car that has got mass 5,000 kgs, moving to the west at a velocity of 10 meters per second. Then here's a situation: they collide, right? And when they collide, let's just say after they collide, this car, of course, let's just say it still has a mass of 2.5 kgs, right? Let's just say it has got a mass of that. So 2.5 kgs. Of course, in metric, the mass does not change most of the time, right? I'll show you all cases. And let's say the velocity it moves after the accident, we all know, right? So let's say it collided, and after the accident, we're on the velocity of this, right? Let's just say the velocity is unknown. So I put a question mark there. Let's say it's not known. But let's say the velocity of the second car is known. So let's say after the accident, it now moves to the west, right? So it moves to the west. So after the accident, let's just say the force was so strong that it caused it to move to the west. So now it's gonna move to the west. Let's just say at a velocity of, let's say, 5 meters per second, right? To the east, actually, right? So it was moving to the west. After the accident, it moves to the east, and it still has a mass of 5,000 kgs. So what is conservation of momentum? Conservation of momentum tells us that the sum of their momentums, right? Meaning when you add the momentum of this and the momentum of this, the sum of the momentum before is the same as the sum of the momentum after, right? So the momentums before is the same as the momentums after. So that's why we have the equation as the sum of the momentums before. Remember, momentum is represented by P, and this sigma means sum. The sum of the momentums before is the same as the sum of the momentums after. So it means the momentum of this one, the sum of the momentums before means the momentum of this plus the momentum of this. But you don't have to write the equation like this. You can just write it as the sum of the momentum. So the momentum of this is the mass, right? So I'm going to call this object A and this object B. So the mass of object A times the velocity, right, times the initial velocity of object A, right, plus the mass of the second object, plus times the initial velocity of the second object. So it's like the momentum of A plus the momentum of B. Remember, momentum is mass times velocity. So momentum of A plus momentum of B before, right? That's why it's written V initial, right? Is equals to, now this is final, right? So the momentum of object A, which is the mass of object A, times the final velocity of object A, plus the mass of object B plus times the final velocity of object B, right? So originally, this is how you must write the equation, right? So this is how you must write it. Okay, in some places they actually write it like this: mass times V, let's just say, of object A, right? Let's just say so instead of putting initial there, they put it outside. It still works, right? It's still valid. And the same thing as final. So they'll say the mass of object B, velocity of object B. Let's say mass, okay, of A, here it's A, and here it's B. And they put there and say final. So it's still valid. You're allowed to do this, right? So I'm going to do it this way, right? The mass of object A, right? So you can just memorize the equation as this. So this is what we're going to do. So what is the mass of object A? Is 2.5, right? So 2.5 kgs times what is the initial velocity of A? See, before the collision, right? Before the collision, it was moving to the west. And before we even do the calculation, we have to choose one direction as positive and one direction as negative. So I'm going to choose my east as positive, or my right as positive, right? So It means whatever is going to go left must be negative. So the velocity of this stuff of object A was 60 meters to the east, right? That was the situation, 60 meters to the east. So that was the initial velocity. So I'm going to substitute it so it's positive, right? Then here we've got the mass of object B, which was 5,000 kgs. And what was the initial velocity? It was 10 meters per second to the west. So it's going to be negative because it's to the west. And then we're going to say equals to the mass of object A, which is still 2.5, times the final velocity of object A. Well, do we know the final velocity of object A? We don't, right? Let's say the question asks us to find the final velocity of object A. So it's gonna be VFA. We'll just put it there as we'll just leave it as a symbol because we don't know it. So what we're gonna do is when I say plus, now I could write here, but I assume the space is small. So let me just write and say. So the mass of object B, which is still 5,000, times the final velocity of object B. After the accident, it moves 5 meters to the 5 meters per second to the east. So I'm just gonna put positive 5 because I chose this side as positive, right? Whatever is moving to the right is positive. So before it was moving to the left, it was negative. Now it's moving to the right, which is positive. So from here, we just have to simplify this stuff and solve for the final velocity. So let's do that. So we're gonna multiply this stuff. You just type this in the calculator. So I'm gonna erase all this stuff and continue. Okay, let me just continue from here, then I'm gonna erase the top. So let's type this in calculator. We're gonna have 2.5 times 60, right? So 2,500 times 60. We don't even really need to simplify part by part. We can just type this whole thing in the calculator. So we're gonna say 2.5 times 60 minus 5,000. Okay, plus 5,000 times negative 10. So the answer of this is gonna be 10,000, right? Not really 10,000 but it's gonna be 100,000. And then now this, when you multiply it, remember it's a number times a letter, so it's just gonna be 2,500 VFA, right? And then now here we're gonna when you multiply 500, right? 500 times 5, that's gonna be 2.5. And then from here, we just need to take this to the other side of the equation. So when we take it to the other side of the equation, it's going to become 100,000 minus 2.5 equals to 2.5 VFA. Right? So we're going to subtract them. So let's subtract them. So that's going to be 97,500, right? Okay, 97,500. Yeah, that's what it's going to be. So let's just erase the top part. So the answer of this was 97,500 is equals to 2,500 VFA, right? And then we just need to divide both sides by 2,500 to get rid of that, so that we can be left with the final velocity of A, right? So let's divide that. So if you divide that by 2,500, we get 39. So it means the final velocity of object A will be 39 meters per second, right? Let me just, so VFA is equals to that, so I'm just going to say VFA is equals to 39 meters per second, right? Now since it's positive, was it to the west or to the east? Remember, we chose west as positive, so we have to also specify the direction and say west. If your answer was negative, on the next line you would remove the negative, then you'll say east because we chose east as negative. But of course it's a positive, so it's west, right? So this part is easy, right? Conservation of momentum is easy. You just always use this equation and then you substitute what was the velocity of object A before, what was the velocity of object B before, what was the mass of object B before, right? Object A before. You just substitute all those things, but you must keep in mind, must bear in mind that you must choose one side is positive and one side is negative, right? One direction is positive, one direction is negative, I mean, right? So bear that in mind. So choose your directions first, and then after choosing your directions, you just substitute what you know in this equation, right? Here is another scenario. So this car was moving at a velocity of an unknown velocity. Let's just say it's an unknown velocity, right? Of it's unknown, right? To the east. So it was moving at an unknown velocity to the east, and it has this mass of 3,000 kgs, while this one is a mass of 2,000 kgs, and it's moving at a velocity of 60 meters per second to the east, right? And then it collides. Then after the collision, this one now moves at a velocity of 0, meaning that it's at rest, right? Or they won't tell you that it moves at a velocity of 0. In the question, they'll tell you it's at rest. So if they tell you it's at rest, then you have to know that velocity is 0, right? It can also be at rest initially, right? So it means that the previous velocity will be 0 if they tell you that it's initially at rest. Now let's say after the collision it's at rest, meaning the velocity is 0, right? So car A, before we don't know the speed, right? But after the collision we know the speed. And then car B now moves at a velocity of 20 meters per second to the east. So before it was moving to the west, after the collision it now moves to the east, right? Then they ask you to find the initial velocity of object A, right? So we don't know the initial velocity. Remember, it says it moves at an unknown velocity, right, to the east. So what do? Well, we just use the formula. We just say the mass of object A times the velocity, the initial velocity of object A, right, plus the mass of object B times the initial velocity of object B is equals to the mass of object A times the final velocity of object A plus the mass of object B times the final velocity of object B. So let's substitute. What's the mass of A? Well, it's just 3,000, right, as it was given. And then what's the initial velocity? Well, we don't know that, so we're just going to say initial velocity of A, because we don't know that. And then plus, what is the mass of B, which is it's actually 2,000. The initial velocity of B, and we have to choose our direction. So I'm going to choose my right as positive. So since this one is going left, I'm going to say minus 60, right? 60 meters per second to the west. So what is my final mass? Well, it's the same, right? 3,000 kgs. And then what is my final velocity? It tells us it's at rest, so I'll substitute 0. And then what is our mass of B? Our mass of B is 2,000. What is our final velocity? It tells us it moves 20 meters per second east, so this one is going to be positive, so 20. And then from here, 3,000 times the initial velocity is just 3,000 vi, right, A. And then from here, this is going to be minus, when you multiply them, right, it's going to be minus 12,000. And then this times 0 just disappears. And then this is going to be 4,000 when you multiply them, right? Of course, you can use the calculators. And then from here, we're going to take this to the other side. So it's going to be 3,000 VIA is equals to 40,000 plus 12,000, because we took this to the other side. All right. Okay, plus 12,000 plus 120,000 actually, right? Okay, so this is going to be 3,000 VIA. It's going to be, when we add this stuff, this is going to be 160,000. And then now we're going to divide both sides by 3,000. Then VIA is going to be equals to, so now we're going to divide them. So this is going to be 16, okay, 160 of course, 1,000 divided by 3,000. So this is going to be 53.33 meters per second, and it's positive, right? So since our answer is positive, right? Okay, I noticed this part wasn't showing, so I divided both sides, right? When we added this, it gave us one answer, right? So to be left with VIA, I actually divided both sides, right? So this is the answer that it gives us. So since the answer is positive, it means it was traveling to the west, because I chose my west as positive, right? So I'm going to say west. You have to specify your direction. Velocity is vector. Vector meaning it's got magnitude and direction. Here is another question. A bullet is being fired up from a gun, right? And it's moving at a velocity of 60 meters per second to the east, right? And its mass is 500 grams. Now it collides into a stationary wooden block. So stationary meaning, of course, you know now VI is 0, right? So it means that VI is 0. So they will tell you stationary, so you have to know it's 0. So it collides into a stationary wooden block. After the collision, they both move at a velocity of 10 meters per second. Then calculate. Now here they will say, alright, so I have to correct my question with something. Okay, let's just say the initial velocity of this stuff was not known. It's traveling at an unknown velocity, right? While the mass was 500 grams, and it collides into a stationary wooden block, which has a mass of 500 kgs. After the collision, the bullet is embedded into the block, right? And it moves they both move at a velocity of 10 meters per second. So this is what you can do. You're just gonna you're just gonna write down the formula. So the mass of object A times the velocity of object A, right? The initial velocity of object A times the mass of object B times, what am I doing, plus the mass of object B times the initial, right, times the initial velocity of object B must be equals to the mass of object A times the final velocity of object A plus the mass of object B times the final velocity of object B, right? We can do it like this, it will still work, right? But there's an issue. It's combined. So when you see a combined situation like this, you have to combine the masses, right? So you can still substitute like this, it can work, right? So if you want to, you can substitute and say, well, the mass is still the same, the mass is 500 grams. Now we have to convert it into kgs, by the way, right? It's in grams. So how do we convert it to kgs? You're just going to have to divide by 1000. So it means it's going to be 0.5. So you can still say the mass is 0.5 kgs times the velocity. The velocity is 10, right? They're both moving at that velocity since they're combined. You can say it's 10, and let's choose right as positive, right? So it means this might be positive plus the mass, the final mass of the block, right, which is still 500 kgs, and then the velocity of it is still 10. So you can do this, right? Some people will actually do it differently. Some people will actually combine the formula. They'll say since this thing is combined and the velocity is the same, they'll just write it as 1 like this. They'll say they'll put it like this. They will actually say mv. So in place of m, they will actually multiply they will add the two blocks since they're combined. So they'll say the mass of this plus the mass of the bullet, so they would combine it and make it one mass and make the velocity 1. But to avoid confusions, I'm just gonna put it like this, right? So since they're combined, we know they're moving at the same velocity, we know their masses are still the same, right? So you can substitute their masses being the same. And then now let's substitute this part. So the mass of object A before collision was still 0.5 kgs, right? So remember it was in grams, we had to convert it to kgs. And then the initial velocity is what we don't know, right? And then plus the mass of object B, which was 500 kgs. I don't know if I ever said 5,000, but 500 kgs. And then the initial velocity, it was at rest, so times 0. Now what you do here, since it's times 0, of course it disappears, right? Then 0.5 times VI is gonna be 0.5 VI, right? VI of what? Of A, right? Initial velocity of object A. And then this, you're gonna multiply it now. So this is gonna become 5. 0.5 times 10 is 5. Then plus 500 times 10, which is 5,000. So 0.5 VIA is equals to 5,005. Then when you divide both sides by 0.5, now this, when you divide it, if you just type this in the calculator, it should be 10,010. It should be that 10,010. Yep, it should be 10,010. All right, it happened again. So this part wasn't showing. So I added this, right, and it gave me this part. Now I had to divide both sides, right? Or I can even repeat the step. So from this step, what I did was to add this, so it gave me 5,005. and then from here I had to divide both sides by that, and then it gave me VIA is equals to, this is 10,010. Now we have to say meters per second. Now, is the answer positive or is it negative? It's positive, so meaning that it was traveling to the east, right? You can also say right or left, up to you, right? And it depends on the scenario. If in the scenario they use east and west, you're gonna use east and west. If they say to the right or to the left, you're gonna have to say to the right or to the left. If our answer was negative, we would have said to the west or to the left according to the scenario, but because the question says west and east, you're gonna say west or east. So if you don't understand anything, you just let me know.